Good afternoon, everyone. My name is Tony Buzalaki, and I'm the president of the University Corporation for Atmospheric Research. And welcome to our UCAR briefing today on weather and climate risks to national security. At the outset, I want to thank Senator Michael Bennet and his staff for making this room available to us today. And I do hope you had the opportunity to get some lunch over there. For those of you that are unfamiliar with UCAR, UCAR is a nonprofit consortium of 117 member universities in North America that grant advanced degrees in the atmospheric sciences. UCAR also manages the National Center for Atmospheric Research on behalf of the National Science Foundation. And the research conducted by UCAR and our partners helps to inform decision makers, and it tries to translate our research into areas that impact society by improving our predictive capabilities for weather, water, climate, and solar storms. And several times a year, we come to Capitol Hill and we bring our members of our community to the Hill to discuss the latest science in areas of importance to policymakers. And that brings us to our briefing topic today. This afternoon, you'll hear about a significant challenge to the United States, the impact of weather events and climate change on our national security. Clearly, this briefing this afternoon was scheduled long in advance of what happened last week in the Bahamas and in the United States, but hurricanes, floods, and other weather disasters are proving to be increasingly costly to our military installations across the globe. And so just last week, we saw Hurricane Dorian forced the Navy and the Air Force to spend millions of dollars to relocate ships and helicopters from coastal bases in Florida and Georgia, and to dispatch the Second Fleet out to sea out of Norfolk. Last year, Tyndall Air Force Base in Florida was severely damaged by Hurricane Michael and is now facing at least a $3 billion rebuilding situation down there after taking a direct hit. Early this year, as you'll hear later, floodwaters severely damaged Offutt Air Force Base in Nebraska. Our overseas military installations are also at risk. Sea level rise is already causing increased flooding near the Reagan ballistic missile test flight area in Marshall Islands. It is imperative that we better understand these weather and climate threats in order to protect our military assets. The United States must leverage its understanding of the Earth system so our troops have the environmental intelligence to keep our nation safe and have an advantage over our adversaries. In addition to the risks to our military installations, the world's changing climate is also leading to greater geopolitical tensions. Sea level rise, droughts, heat waves, and more powerful storms are creating new stresses for the nation around the globe. Our panelists here today will be talking about these challenges, as well as strategies to safeguard our national security. To my left is David Easterling. He is the director of the National Climate Assessment Technical Support Unit at NOAA's National Centers for Environmental Information. His expertise includes the detection of climate change in the observed record, particularly changes in extreme climate events. He has authored or co-authored more than 100 research articles in journals such as Science and Nature, and he is also a contributor to the assessment reports issued by the Intergovernmental Panel on Climate Change. Today's left is Sherry Goodman, who is a senior fellow at the Wilson Center and an advisory board member at the Center for Climate and Security. Previously, Sherry served as the first Deputy Undersecretary of Defense for Environmental Security and as a staff member on the Senate Armed Services Committee. She has founded, led, or advised nearly a dozen research organizations on environmental and energy matters, national security, and public policy. And to Sherry's left is Vice Admiral Dennis McGinn, who is a senior advisory board member at the Center for Climate and Security. He served as Assistant Secretary of the Navy for Energy, Installations, and Environment from 2013 to 2017. Previously, he served on active duty in the U.S. Navy for 35 years as an aviator, test pilot, aircraft carrier commanding officer, and national security strategist. His capstone assignments as Vice Admiral included serving as Deputy Chief of Naval Operations and as the Commander of the United States Third Fleet. And so our format today, we'll be hearing a series of presentations We'll enter into a discussion amongst the panelists, and then we'll open it up for questions. And I'll be leading things off. Let me start with a sort of a global perspective and backdrop for today's series of presentations as it pertains to environmental security and political instability. We speak about environmental security. Let's go back about 12 years. 2007, the United Nations estimated that all but one request for emergency aid in that year was climate related. And things have just gotten worse since that period of time. And when we talk about environmental security, it really transcends more than just climate change and weather, but encompasses a range of multiple stressors, such as population growth, human health, changes in land use, water quality, quantity, and influences on government stability, such as conflicts over resources such as water, food, energy, impact of sea level rise, opening up of the Arctic, population migration caused by desertification, flooding, and sea level rise. Water stress is one of the prime examples of such. And so over the next 20 years or so, demand for water will continue to rise to support food, energy, and mega cities. Over 600 million people across the globe lack access to clean water right now. And the World Bank estimates that by about 2025, 80 to 100 million people will be exposed to water stress, particularly in the Mideast, where about 33 of the 14 of the 33 countries in the region are expected to be exposed to serious water shortages by 2040. Now, if we sort of take from this map of water stress and then look at projected changes in agriculture toward the end of the century, we see at higher latitudes increased agricultural productivity, but across a wide swath, oftentimes following water availability, a wide swath of countries in the developing nations, rather significant decreases in agricultural productivity, including large parts of the United States. And these are continental scale projections and really doesn't even take into account the more regional impacts due to severe events such as hurricanes, droughts, and severe flooding. Now, over the past 8 years, I've had the great pleasure of serving on 2 Academy of Sciences studies dealing with climate change and national security. The one on the left I had the good fortune of chairing with 4-star retired Admiral Skip Bowman. This was commissioned by then Chief of Naval Operations, Admiral Roughead. We're looking at the security implications of climate change for U.S. naval forces, U.S. Navy, Marine Corps, and the Coast Guard. And because of the Navy's forward presence around the globe, one of the findings was that climate change effects are already being felt on the world's oceans and beyond, some effects directly impacting national security and U.S. naval forces. Study on the right, I had the great privilege of serving on with both Dave and Sherry, funded by the intelligence community, looking at the implications for political stressors overseas. And one of the findings here was that the U.S. government should begin immediately to develop a systematic and enduring whole-of-government strategy for monitoring threats connected to climate change. And among one of the recommendations was, much like the stress testing of banks, to look at climate hotspots around the world where the social fabric and the governance of regions and countries was tattered, such that a climate or extreme weather event may push a particular society or region over the edge. So, with respect to the findings for the Navy study, there was 4 main areas, chief among them being the Arctic. And the Arctic is an area going forward that is likely to be a region of cooperation amongst countries, competition for resources amongst countries, and albeit low, the possibility of conflict. The Arctic, though, is going to remain a very harsh environment. It's a remote location. We do see already signs of increased maritime traffic, recreational ships and commercial vessels going up there. Yet it remains an area of limited infrastructure, long distances, lack of ports. Going on to other parts that impact the Navy mission, In this report, we predicted an uptempo in the response of the U.S. Navy for humanitarian assistance and disaster relief. Exactly what we saw last year in Puerto Rico with respect to the Coast Guard and the U.S. Navy's presence in Puerto Rico, and what we're seeing right now with the Coast Guard and the U.S. Navy in responding to the tragedy in the Bahamas. Increasing need for global partnerships. Going back to the Arctic, post the Cold War, we sort of lost our experiential edge in training in cold regions. And now we're starting to see more collaborations with the Canadians, for example, joint missions training in this harsh environment. Need for adaptation to climate change-related sea level rise. Something on the order of $100 billion worth of U.S. Navy installations, $100 billion, are vulnerable to 1 meter rise in sea level. And as I said, for the agricultural plot, there's also a need for more improved forecast skill at the regional scale. To sort of bring our focus down to the scale of operations, or the arena of operations for the DoD. With respect to the intelligence community study, some of the findings include need to take into account and be prepared for climate surprises that may affect particular regions or global systems, such as grain markets and their supply chains. That climate effects will increase to the point that they exceed the capacity of a region or society to manage, cope, and adapt. Some parts of the world aren't that resilient. And the need to bridge the physical sciences and the social sciences to improve our understanding of how weather and climate disasters may disrupt and lead to political instability and violent conflict in the region. And this was an unclassified study, but one of the case studies that we focused on was Pakistan. So we hear a lot about competition for water resources between India and Pakistan, but Pakistan unto itself is very dependent on river flows, precipitation, access to water. And the situation in Pakistan is such that during times of drought, a decision has to be made with respect to how best to use those water resources. Is the water diverted into the cities for power generation, or is it diverted into the agrarian areas, the rural areas, for agricultural production? And when water is diverted for agricultural production, leads to brownouts and blackouts in the major cities such as Karachi, and huge, widespread civil unrest that we don't hear about a lot in the West. But yet, again, this is a country that has the bomb. And so very vulnerable to the impacts on climate for this part of the world and the issues of political instability. And to get more into summary mode, here's a plot that we generated to sort of summarize the impacts of weather and climate risks for the U.S. combatant commands across the globe. So upper northwest is U.S. Northern Command that is vulnerable to wildfires at the Vandenberg Air Force Base, hurricanes as we've seen in the southeast and just last week in the East Coast. We have African Command and its dependency on water and what water means to crops, issues with respect to subsistence fishing offshore and its how that's going to change with respect to ocean acidification. South Command, we're now starting to see tropical cyclones, hurricanes in the South Pacific, an area that's very vulnerable to increases extreme precipitation and reliance on, and what that means for disease vectors such as malaria, dengue, and Zika. We have over here in the Southeast Theater the impacts of extreme flooding events, typhoons, landslides within the region. And so to summarize then, some closing thoughts, something on the order of around 3,500 military installations around the world. And right now, the biggest impacts as reported by the DoD, are drought, followed by wind and non-storm surge related flooding. But what we are seeing, because of the deployed presence of the DoD around the world, that climate change is intensifying these disasters worldwide, increasing the risk of food and water shortages, and what that means for these vulnerable regions around the world. And what we're also seeing is essentially, when I look at these extreme events, an acceleration of the hydrological cycle around the globe. We have larger, more sustained, stronger droughts, and at the same time, seems contradictory, but at the same time, we're seeing more floods, more increased precipitation events, and actually, the next presentation, Dave will give you basically the physical reason why. So lastly, our national security requires a comprehensive, government-wide strategy that relies on the best available science to build resilience to extreme weather in a changing climate. And so, following from me, Dave's going to talk more about the observations and the science, and then our last two speakers will have a presentation and a discussion of what the implications are and what has actually been experienced by our military forces. So, Dave?
Thanks. So as Tony said, we're going to switch gears a little bit, and I come from the NOAA National Centers for Environmental Information in Asheville. We are the world's largest archive of weather and climate data, and so one of the things that we do with all those data is we describe the climate of the U.S. and the world, and we monitor it, and we do research on climate change. So what I want to do today is to go through some of the observational evidence mainly for what's actually happening currently in the climate, and a little bit about how that's impacting military installations. Okay, so this is a graph that we produce at NCAR in Asheville as a part of our monitoring mission. And this is the globally average surface temperature from 1880 to the present. This is in degrees C on the side here. And this is basically where we've averaged up all the temperature observations from stations on land, all the sea surface temperature measurements in the ocean, including satellite measurements, and come up with one number for the globe, sort of like taking your temperature. And what we see is that starting in 1880, temperatures kind of went down about 1910, went up to the World War II era. There's some uncertainty in here. A lot of that is because of the uncertainty in sea surface temperatures during the war effort. Hard to get some of the data out of some of these countries. But what I really want to focus on is what's been happening since about 1970. Okay, if you look at starting about 1970, global temperatures have gone up rapidly. There's been some peaks and valleys in here. And this is the so-called hiatus, if you heard about that a few years ago, where people were saying there wasn't warming. Actually, it was less warming than has been seen since 1970, but it still warmed. But I also want to point out that here, in the year since about 2016 to the present, it's been the warming has continued, so it's gone up. And we've seen an increase in globally average temperature of just about a degree Celsius. Doesn't sound like a whole lot until you think of how much energy that takes to warm the climate and what the implications are for the climate system. Okay, why is it going up? One of the reasons is, or probably the primary reason, is increasing greenhouse gases. These are measurements at Mauna Loa. NOAA has an observatory on top of Mauna Loa in Hawaii, and the reason why it's on top is you want to get up into the free atmosphere, up above all the inversions, and measure the background amount of trace gases. Trace gases being methane, nitrous oxides, and carbon dioxide. And as you can see here, measurements started in 1958 and go up to the present. There's a stair stepping, which is basically the green up and green down of the northern hemisphere. But the bottom line is CO2 started in 1957 at under 320 parts per million. It started in pre-industrial levels at about 260 parts per million. And it is now over 411 parts per million. And you can see that it's almost an exponential increase in the amount of carbon dioxide in the atmosphere. Methane is a very powerful greenhouse gas. If you looked at it molecule for molecule, it exists in the atmosphere in smaller quantities, but it is still a very powerful greenhouse gas, and methane is going up. Nitrous oxides are going up, and other greenhouse gases continue to increase, mainly due to human activities. Burning of fossil fuels and deforestation are the main things. So what are some of the other things that we look at in terms of climate change? What are some of the other variables or elements we look at? One of them, Tony mentioned this, is sea ice in the Arctic. So you remember the Arctic is all ocean up there, covered with sea ice mainly in the wintertime. And these are two satellite images, one from 1984 and one from 2016. And look at the difference in ice cover. This is in September. Okay, and September is when you have the least amount of ice cover up there because of the melt through the summer. You have almost the entire Arctic covered up here, and then over here you see how much of it is open ocean. And if you look at this graph, this time series is simply sea ice cover in millions of square miles. It started off at about 3 million square miles in the late 1970s when satellites first went up that we could use to measure this. And it's reduced in September down to almost 1.5 million. So you've had about a 50% drop in ice cover. Okay, and this is just an example of a Navy ship, the Normandy, just north of Iceland, going into some of these ice fields. Okay, another measure, and this is one that I kind of call a big integrator because it's hard to deny sea level is going up. A lot of people look at the data for things like temperature, and they're a little bit skeptical. But if you look at sea level has gone up almost 8 inches. This is U.S., but also globally, almost 8 inches since about 1900. This starts in 1920. This is from tide gauges, NOAA tide gauges. They're stair-stepping here. The reason why is due to things like changes in El Nino and ocean currents and stuff like that. But the bottom line is it's gone up almost 8 inches, actually probably a little bit more than 8 inches. And it will continue to rise as we warm the climate. And it does have major impact for things like this is in the Marshall Islands, and just shows you an example of what we call sunny day or nuisance flooding. So when you get a very high tide, suddenly the streets that are near the ocean begin to flood. And it's a big issue for places like Camp Lejeune, Norfolk. And it's also a big issue for cities around the country. If you look at Miami, Charleston is spending millions of dollars putting in a drainage system for these kinds of incidences because nuisance flooding has gone up a lot. Okay, what about tropical cyclones? Tony mentioned tropical cyclones. So it's an area of active research, how they might change in the future and if they have changed in the past. The numbers are uncertain because of the way that measurements of tropical cyclones occurred. So prior to World War II, if a cyclone didn't hit land or a ship, you didn't know it was out there. Okay, so it may not get counted. After World War II, aircraft observation started, so they started flying hurricane hunters out to measure the storms. But starting in the late 1960s or so, we have a satellite record that catches almost all of them, or actually all of them now. We know exactly how many tropical cyclones have occurred. This is just the cyclone tracks for 2018. We had 2 that really had major impacts in military installations. This is the track for Florence, went into North Carolina, and was a very, very slow-moving storm. There's one thing that recent research has shown is that tropical cyclones are now moving up to 17% slower than they used to, okay? And a slower moving storm means you get higher rainfall amounts, and that's exactly what happened in Florence. Florence went in right around Wilmington, North Carolina, and some stations measured over the course of 3 days over 30 inches of rain. And it was moving at one point where you could walk faster than the storm was moving. So that has major implications. What's going to happen in the future? So the number of tropical cyclones in the future is uncertain. Models don't necessarily resolve those kinds of storms that well, but the research does indicate that we expect them to be more intense when they do occur. So there'll be heavier rainfall and stronger winds. And this is just an example of what happened with Hurricane Michael at Tyndall Air Force Base. Blew the roof off of this hangar, and that's probably minor damage compared to what other parts of the base endured. Okay, another strong signal in climate change is in the observed record is an increase in heavy precipitation events. So this map shows you by region. This is for the U.S. National Climate Assessment that we just put out in November. And it shows you the change from 1901 to 2017 in what we call very heavy 24-hour rainfall events. And you can see that everywhere in the continental U.S. and Alaska has gone up. Some areas like the Southwest have only gone up 5%, but the Northeast is seeing a 70+% increase in the number of these events. And these events, of course, lead to flooding. So this is an example of what happened in March at Offutt Air Force Base. They couldn't use the runway because part of it was underwater. Okay, I want to switch gears slightly and say, DoD, the Department of Defense, is aware of a lot of these issues. They do have a research program looking into a lot of these environmental issues, especially with climate change. And I have a project with a colleague of mine from NC State University where we're looking at, as the atmosphere warms up, it can hold more moisture. Okay, and this is just an example of that relationship, that as the temperature increases, the amount of moisture increases as well, and it's exponential. So as we have a warming climate, and as the climate continues to warm in the future, we're going to have more water vapor in the air to rain out in these heavy rainfall events. So what are we looking at? So we're looking at recurrence intervals for these kinds of events. So this is, you all probably heard the 100-year flood, the 100-year rainfall amount. Okay, well, that's the amount that is, the probability is 1% in any given year that you're going to equal or exceed that amount. Okay, that's why they call it 100 years at 100%. Okay, so this is at Fort Bragg, and the 100-year, 24 hours, this is how much you would expect once every 100 years on average, you would measure at Fort Bragg is about 8.23 inches. Okay, well, how is that going to be 50 years from now? Is that going to be 10 inches? Because we've had a warming of the climate, more moisture in the atmosphere. So that's what we're looking at. These kinds of curves are used by civil engineers to build these structures like runways and culverts. Well, do they need to build them 20% bigger to be able to handle the increase in heavy rainfall amounts? So that's the question we're trying to answer, and provide this for all the military installations in the U.S. and abroad. So this is a really nice infographic that kind of summarizes what's happened in the climate system in the observed record and how consistent it is with our understanding of the physics. Okay, so if you look at here, all indicators that are expected to increase in a warming world are increasing. Okay, so we got water vapor going up, and these are all based on studies that have been done over the years. Temperature over the ocean, sea surface temperature is going up. Of course, I mentioned sea level, that's going up. Ocean heat content, so this is the amount of energy in a layer from the surface of the ocean down to about 700 meters deep. It's been measured over about the past 60 years. That's increasing. Temperature over land is increasing. And these black arrows show the ones that are decreasing as we would expect. Alpine glaciers and ice sheets over Antarctica and Greenland, their mass is decreasing. Snow cover is decreasing, and sea ice, which I showed before, is decreasing. So I just want to wrap up with some concluding thoughts. So extensive independent observations confirm the reality of a changing climate, and that last infographic is a really good example of that. These changes are broadly consistent with understood physics and predictions of how the climate system is expected to respond to an increase in greenhouse gases that we have observed. And lastly, these changes are already impacting military installations and operations. Thanks.
Sherry?
Okay, good afternoon. It's a pleasure to be here with you all. And we're going to mix up the format a little bit now. I'm going to use my slides as a way to have a conversation also with my colleague, Admiral McGinn. And we're going to take these excellent presentations on the science, on weather and climate security, and look at it through the lens of national security and military experience. So to me, it's very fitting that we're here today on 9/11 as we pay our respects to those who lost their lives in those tragic events of that date. And we think back to our colleagues and loved ones who were lost. And then we also think about what are the most important threats to our nation at this time, and how do we best prepare ourselves for the future. Now, thank you. Okay, so if we think back to military operations throughout history, and I've just picked one here, D-Day, 1944, and think about how important weather forecasts have been throughout history. incredibly important. And we actually know on 9/11 that the websites that the terrorist attackers were checking most often were those about the weather. Okay? So now we live in a time where weather is much less predictable than it has been in the past. So understanding it becomes even more important and preparing for it. Denny, maybe you want to share with us from now Denny's got many years of military experience, leadership in the Navy. How about a military operation in which weather was fundamental to your experience?
You use a very good example, Sherry, here of D-Day, very, very dramatic. And I'm glad that you reflected on the weather aspects of 9/11 on 2001, 18 years ago. Those terrorists were checking the websites because they were not able to fly instruments in instrument conditions. They needed a clear day to be able to fly the airplanes to the targets that they had pre-selected. In between D-Day and 9/11, 2001, there have been many, many operations that have had to be canceled or changed or what have you as a result of weather. One of the most dramatic was in about 1980 when we had the Iranian hostage crisis. There were many Americans that were being held in Tehran. We launched a raid, special operations helicopters and C-130s flying up into Iran, into the desert. And the mission failed because of unpredicted sandstorms. That had they been known, the mission would have been postponed or withheld until the weather was going to be more predictable. And there are literally thousands of examples where small tactical operations and large strategic campaigns have been either adversely affected by the weather or have been changed as a result of whatever good information there was available by the meteorologists and scientists to be able to tell them what kinds of conditions this was going to be. One final point. In the national security business that Sherry and I have been in for decades, our planning horizon isn't next week, it isn't next quarter, it isn't next fiscal year, it isn't even the 5-year defense plan. It is literally decades looking down to try to figure out what exactly is the strategic global environment in which our national security and our military forces are expected to perform, to have the right capabilities and the right capacities. This is where climate science and all the measurement that is necessary needs to be known, the environmental intelligence, if you will, because the more we know about the conditions in which our troops are going to be training here in the United States, or the conditions which may cause unrest and instability all around the world affecting United States interests. So this idea of you manage what you measure, we need to measure more so that we can manage our national security apparatus, not just this year or next year, but literally decades in the future. And it needs to start now.
Okay. Well, we've served together for many years, but we started working together specifically with the Center for Naval Analysis Military Advisory Board back 12 years ago, when a group of about a dozen generals and admirals, 3 and 4 stars who've served across all the services and all the combatant commands, came together with me at the Center for Naval Analysis to form the Military Advisory Board, and we released this first report in 2007. Now, it's instructive, I think, for those of you who are staffers here, and I was once in your shoes 30 years ago, now working for Senator Nunn on the Armed Services Committee staff, as about how you can use a report to actually help it advance, your legislative objectives. The week this report was released in 2007, its primary recommendations were included in the Defense Authorization Bill that was being marked up in the Armed Services Committee, bipartisan inclusion, and it requires now for the last 12 years for the National Security Strategy, the National Defense Strategy, and the Quadrennial Defense Review, which are all defense policy documents to address the national security implications of climate change. And we characterized climate change as a threat multiplier for instability in fragile regions of the world. And we see now that it affects even stable regions, even our own homeland. We've seen that increasingly over the last decade. And I would say to you, those of you who are in the think tank academic world out here, and I know there are some of you, it's instructive as to how you can craft your work, your research, and your report and your writing so that it can be useful for those of you who are the staffers and the legislators in the room who want to turn that research into action. So there's some art to that, but it's useful to sort of understand both sides. So, and we, as I said, we characterized climate change as a threat multiplier. This is of showing the changes in the heat map, but at any variable you pick, whether it's heat, whether it's melting sea ice, whether it's sea level rise, extreme weather events, as was David showed on his very last chart, you can see that it's aggravating all of the dimensions of our national security. And Denny, you and I have served, we produced these 8 reports across now a decade, looking at a range of climate and national security and energy impacts, most recently at water stress and national security. But perhaps you would share with us a story of yourself or one of the MAB members as to why, after having served as a warfighter for decades, you decided that this was something important to you.
The phrase that climate change and the adverse weather effects, severe weather effects that accompany it, not are going to, but already accompany it and will increase in the future, acts as a threat multiplier. That causes the fragile states and nations and areas that Sherry just mentioned to fail. Lord knows there's a lot of challenges out there. There are fault lines along economies, religious lines, ethnic lines, boundaries of nations. And when you start having much more frequent and much more severe weather effects, that pressurizes those fragile governments and fragile societies, and they fail. That is a recipe for more mission by our wonderful young men and women in uniform now and decades to come. It can be on the relatively low end of humanitarian assistance, disaster recovery. On the high end, it can go all the way up to regional war. The example that Tony used of the study that focused on Pakistan and water distribution, that is not just within Pakistan that it is a challenge now and in the future, but in an area of South Asia that already has enough tensions along political and religious lines, in Kashmir, to name an example.
Okay, so just taking that a little further, we train like we fight. So when we're training, whether in the Southwest or our troops are deploying, in places like Pakistan and other parts of the Middle East, as temperature rises, so do the black flag days when it is too hot, consistently above 90 degrees Fahrenheit, for our troops to consistently be exposed to that without health risks. So we see that this is directly affecting military readiness. It also, in a number of cases, and this now I'm drawing on testimony I gave before the House Foreign Affairs Committee earlier this year, is emboldening our adversaries. And although I don't have my Arctic slide in this deck today, but you saw some Arctic slides, nowhere is this more true than in the Arctic. We have a whole new ocean that has opened up in our lifetimes. And Russia, for example, sees the Northern Sea Route that runs along its coastline as a future toll road for shipping from Asia across to Europe. And China has declared itself a near Arctic stakeholder and is building the Polar Silk Road, where it hopes to use those shipping lanes and then extend its global quest for resources throughout the Arctic. So we now see a whole new geostrategic region that is changing because the sea ice is retreating, the permafrost is collapsing, and the ocean temperatures are rising. This is also true across Africa and parts of the Middle East, where temperatures are rising and drought is spreading. You find that terrorist groups, from Boko Haram to Al Qaeda and its various affiliates, are taking advantage of the food and water scarcity that is becoming more prevalent in various regions, such as the Lake Chad region or other parts of the Sahel, and putting vulnerable populations either at risk, withholding those supplies, potentially contaminating them, or using it to sort of control the people within that increasingly resource-poor region, exacerbated by these climate impacts. Okay, now to our military bases, which have suffered significantly in the hurricane trains of the last several years. We've talked about Tyndall Air Force Base in Florida, Camp Lejeune Marine Corps Base in North Carolina, both hit by the storms of last year. Extensive damage. Those are estimates of the damage to rebuild those bases, and those estimates don't properly account for what it takes to rebuild them to withstand the next stronger storm. So we see that we're not yet really prepared to operate in this climate era. And so this is affecting our military readiness as well. Now, the Air Force has recently, this is just an example, Air Force has decided it needs to address long-term weather threats, and the Air Combat Command, which is where the command of the Air Force, our fighters, that contains our fighters and bombers, General Holmes, the commander, has commissioned a study to look at those long-term weather threats, whether it's the changes to the bases or the changes to how we operate aircraft in hotter temperatures as well. You got a story on that one too, Denny?
It takes a lot longer runway to take off in hot weather. And in fact, you see this in the civil aviation. If you fly through Phoenix or Albuquerque or places like that, it never used to happen, or it seemed very rare, but they have to actually download the amount of fuel or number of passengers on airplanes to accommodate for increased temperatures. This is true in the military. You can't go as far, you can't carry as much supplies or weapons or what have you as you operate in hotter and hotter climates. I want to also emphasize the point that Sherry made about we train like we fight. So the instability and threat multiplier creates more mission, but our ability to meet those mission needs in our training is diminished. I'll give you two examples, one with too much water and one with not enough water. In the Tidewater or Hampton Roads area of Virginia, major military complex for Army, Air Force, Navy, Marines, and regular blue sky flooding because of sea level rise, for example, happens there. But Lord forbid, when you get somewhat of a northeaster or a hurricane, even a Cat 1 or 2 that produces surge, storm surge, floods areas where sailors, soldiers, airmen, and Marines can't get to and from their duty station without trying to wade through a flooding of some sort. The other extreme, where there's not enough water, Camp Pendleton, major Pacific base for our Marine Corps, from which they deploy downrange to the Indo-Pac region. And it is not uncommon, because of high temperature black flag days, to not be able to go out in the field and train in a realistic environment. And even more importantly, the wildfire danger prevents the Marines from training with live fire ammunition like they're going to have to use when they go over and face the enemy. So increased mission requirements, decreased ability to train for those missions.
Right. We call that sort of increased op tempo and degraded military readiness. And you can see here on these maps the military bases in the U.S. that the Department of Defense has identified as being at risk for various factors from flooding, wildfire, higher temperatures, wind, and drought. And those are just the military bases, but as you know, in the hurricane events, the storms, or the wildfires, they are not confined, of course, just to the military bases, but our military now is often called upon to provide what we call defense support to civil authorities, but at an increasing rate, whether it's the hurricane, the storm surge, or the wildfire. So our military, in the first instance, our National Guard, but then supported by the active duty and reserve, are being called up to support these missions here at home. In fact, we've had to slow the flow of forces overseas in order to support missions at home on an increasing basis. And this is something that is still fairly new in military planning, because traditionally we have not sized our force to provide for the Homeland Security mission. We have assumed that it's a lesser included case in the away game of fighting the enemy out there. But increasingly, we have to be able to be agile and provide forces necessary to support the Homeland Security missions as well. Okay, this is a little deeper dive on the impacts on Hampton Roads infrastructure. Hampton Roads, Norfolk, the greatest complex of military installations in the country, perhaps in the world. 17 military, no, it's probably more than it's 17 towns and more military installations than that for all the services, plus a NATO command that was recently reinvigorated, the Second Fleet, which providing support to NATO across the Atlantic and up into the high north. As Denny said, there's sunny day flooding, coastal erosion, subsidence, and although it's narrowly missed the center of the recent hurricanes in the last couple of years, it still felt those effects and is increasingly vulnerable. Okay, so to say, okay, what can we do about this? What should we be doing about this in a weather climate prediction context? It's about improving our predictive capabilities. And these are some of the findings from work we did with UCAR, NOAA, and the Wilson Center last year, where we looked at 3 different case studies: Pakistan, and Tony's talked about the Pakistan case study, Caribbean, and Horn of Africa. Each are areas of the regions of the world that are increasingly affected by disruptive weather and water events, whether it's increasing drought, floods, or a combination of both, or increasing storms, extreme weather events, as in the Caribbean. And how do those changing ecological factors integrate with the political risk and the social risk to create the geostrategic risk? And what can improved weather and Earth system predictions do to help us get ahead of that curve? And I won't read you all those findings there, but the bottom line is that we need improved Earth system prediction capability, which is another way of saying environmental intelligence, or advanced weather, seasonal to subseasonal forecasting that helps us have greater what we would call domain awareness and observations in any region of the world in which we are operating. And Denny, I know you had a chance to serve not only in uniform, but within the last several years, you've also went back into the Department of Defense as a civilian. And maybe you could just share a story about how you have been able to try to apply that in your own work.
During the decades of military service and then subsequently as Assistant Secretary, I learned that I do a lot better job solving problems that I know about. And this idea of measurement is so critical so that we can know about problems, the scope, the scale, the timing to the extent that we possibly can. We've got wonderful supercomputers throughout the nation and working on environmental intelligence, for example, but we're not where we need to be in terms of the granularity and the specificity that we think is possible to get to so that we can really understand much better the effects of environment and climate on military operations. In listening to the challenges that we have been describing and will continue to describe, you could really get depressed. But I'm telling you, we have a lot of things that we can do about it. And one of the best things is let's define the problem even better than we can now, because this country has a tremendous, tremendous record of being able to rise to all sorts of challenges. Sherry's referral to D-Day in 1944, thinking back on 18 years ago, 9/11, we can respond to problems to the extent that we can know more about them before they happen and perhaps even avoid or mitigate them. We're in a lot better shape.
Great. Well, and you see signs, and I just close by saying that in some of the bills that are pending this year, I know the Defense Authorization Bill, and I think, and in some of the other bills, there are pieces of this work that are being, of these needs that are being reflected. The Defense Authorization Bill, for example, includes requirements to develop military installation resilience plans, which will help incorporate climate predictive tool sets into that work, which is sort of a piece of addressing this. There's a lot more we can do. And thank you for your time today, and I hope you take this up as an important element of your own work.
Sure.
So as a segue, I'm going to pull up a couple of slides for Denny to speak to with respect to resilience.
We mentioned resilience, and this is just a graphical representation. System performance is on the vertical axis on the left-hand side, and the event timeline is on the horizontal axis. Basically, if you start up in the upper left-hand corner, we're functioning as a system, national security system, one of the services, a ship, a squadron, an army division, what have you, and something happens. That is that adverse event occurring. And it basically could be a typhoon, it could be a major drought, it could be a wildfire, but something happens that degrades, sometimes very rapidly, the system performance. We get into let's absorb the initial shock, let's start to recover, and then let's start climbing back up to that system performance level that we had before the event. And this is where, by learning the lessons of that Mother Nature is teaching us and has continued to teach us for many, many years, we can adapt, we can build things stronger, more resilient, whether they're energy systems or whether they're transportation, bridges, what have you, drainage systems. We can make ourselves tougher as a nation, as a military service, as a society by understanding what the challenges are going to be, what we have learned from past challenges, and they can anticipate up front. A simple example, Dave used the example of 100-year events, rain events. I would use the example, if you have a military operations center in a 100-year FEMA floodplain, don't put the computers in the basement. Not a good idea. And if you've got a backup power system that works fine when the birds are singing and the sun is shining, but when the wind blows or the water starts flowing, it floods out the fuel system or the substation transformer. We need to think and we need to build more resiliently. That's my message, if you will, on resilience. We can, in fact, do something about it.
So both thank you and Admiral McGeehan for that exchange there. That was very constructive. We have time now. I'd like to open it up to the floor for questions for any. Do ask that you come to the microphone and ask any questions to our esteemed panel. please, and identify you.
Name and social security number, please. We'll take your photo.
Hi, Rennie Myers. I was wondering, going back to that resilience diagram, you point to adaptation in that final section, but what about mitigation efforts within the DoD and DHS to lessen climate change or greenhouse
Right.
gas emissions?
Great question. Mitigation can make that the depth of loss of system performance much shallower if you are in fact are mitigating the effects of a potential adverse event. You also can shorten the time to recovery to get back up to full mission performance. So absolutely, mitigation is key.
You know, DoD has been lowering its carbon blueprint, if you will, over the last decade or so by moving to lower carbon energy systems, testing out new forms of alternative forms of fueling aircraft and ships, also improving the efficiency of its buildings and infrastructure, and you know has had various goals from net zero. Net zero bases was an Army objective, and each of the services has set various stretch goals for itself to address how it reduces its carbon emissions.
Nathan Grant. So you talk a lot about predictability and the importance of being able to predict weather. But my understanding of the science is as climate change progresses, the weather will become increasingly unpredictable. So what steps can be taken to predict the increasingly unpredictable?
Well, yeah, I actually not certain I agree with that statement. And what we're seeing across the world, in the United States and overseas, is our approach to both weather and climate is kind of coming together. And the jargon we use is seamless prediction. And so now what we're starting to see is the climate change models that had real coarse resolution are now getting to the point where the climate models are actually starting to resolve weather. And so we're just beginning to start looking at what will be the shifts in the distribution and so of severe events and severe storms. And so that's why we don't have a definitive answer right now with respect to how hurricanes are going to change in a warming climate. I'll give you one example why it's a difficult problem. All right, so as Dave said, we expect more water vapor in the air, more sources of energy for severe storms. All right, but when we have an El Nino in the Pacific Ocean, what that means in the Atlantic oftentimes is suppression of Atlantic hurricanes and keeping the storms further out to sea. And what happens is you have rising air in the Pacific, comes over to the Atlantic, and it descends and it shears off the tops of the hurricanes. So what happens to El Nino in a warming climate? And that is really still an open question. So the models are getting to that point where they can resolve weather, climate variability, shifts in climate variability, and the impacts in climate change. We're not there yet, and we haven't built up that sort of that set of statistical runs. We can create this distribution, but the computational horsepower is now getting to the point where we can actually look at extreme weather events in a climate projection scenario. Dave?
And just to add to that, so you started off by mentioning short-term predictions. So what's it going to be like next week in Washington, D.C.? Okay, those forecasts have gotten so much better in the last 20 and 30 years. It's unbelievable how much. It used to be 2 days out was a good prediction if your prediction came true. Now you're up to almost a week in a lot of instances. And that's due to improvements in the models, supercomputing, as well as our understanding of the entire climate system. How is El Nino going to impact it? That sort of thing. So in the future, short-term prediction, I think, is going to get even better and better. It's the longer term. How are the big features of the climate system like El Nino going to change that do have impacts?
And that's why Sherry referred to Earth system prediction. So we've moved from our knowledge of predicting the atmosphere, and now we've begun to better understand how the ocean, the atmosphere, the land surface, and the cryosphere come together, couple with one each other, that allow us these longer time predictive timescales. Yes.
Good afternoon.
Nanette Sadusky. So I appreciate if you could reflect a little bit on just how critical it is to increase the amount of actual in situ observations, because how important they are to enhance our environmental modeling.
Yep.
Thank you.
So I think a good example is what happened this past week with Dorian. The track forecasts, for the most part, were good, and we're not going to discuss anything else beyond that. But where the models were...
How is that affecting Alabama? Can you comment on that?
Next question, please.
Next.
So, where there's need for improvement, and this is not a U.S. issue or a European issue, both had issues, is the rapid intensification. None of the models really predicted that rapid intensification to Category 5, nor did either the European model or the U.S. model predict that Dorian was going to squat for 40 hours over the Bahamas. And observations get to this. And so in terms of better constraining and better understanding those large scale steering currents, we need more on-demand in situ observations. And then to better understand the rapid intensification from, let's say, Category 3 to 5, we need more observations of basically the atmospheric dynamics in physics, as well as the coupling between this heat content that Dave Easterling was talking to, this coupling between the ocean and the atmosphere. So two areas, more focused for rapid intensification, more broader scale observations for what's going to happen, let's say 2, 3, 4 days in time.
Yeah, if I could just add to that, a different perspective is the fact that, so I showed you that temperature curve at the beginning. So that is based on in situ observations from weather stations all around the world, thousands of them. Okay, unfortunately, they cost money to run. And a lot of countries are closing down stations. For temperature, it doesn't take that many to get a good idea of what's happening in terms of temperature. Precipitation is a highly variable across space. And so it can be rain, everybody's experiencing it. It's raining over here, it's not over here. Okay, to be able to capture that, you need more stations. And we need to keep stations open that we have for that longer term perspective. We also need more in places that we don't have stations.
And I want to thank you, Nanette, with the Navy Oceanographer's Office for asking that question, because it is, and I see a number of people here who have experience working in and with the military, because the Naval Oceanographer's Office, the Air Force Weather Office, these are fundamental capabilities that our military operators use to inform their decision making.
Good afternoon, Ruben Vassar, here with Howard University's Atmospheric Science, but I'm also Army Warrant Officer out of Geotech. So I deal with satellite imagery, drones, ground-based systems. I just got back from Afghanistan in May, and as I'm looking at what we're doing on the ground, a concern for me is what we're getting ready to go back into, which goes back to your slide. We're going back to fiscal. All right, so we're not going to be able to go into these countries and just fly in there, deploy our drones, and understand what they're doing. It's going to be China or Russia, somebody that has a peer-to-peer type of threat. Has anybody looked at the effects of the climate on our space-based sensors? Like, are we going to actually be able to deploy these sensors to see what Russia and China is doing? Is anybody looking at that?
Let me start by saying that our overhead or space-based intelligence, surveillance, reconnaissance capability is changing. We've lost some capabilities, but we've added more and more on in terms of smaller, more capable satellites that are much more numerous. So our coverage is changing. In the past, where we've had to have either geostationary or equatorial type of orbits, or once in a while polar orbits, the scan time over a particular target, whether it's well, pick a country, is getting a little bit better than it has been in the past. I think we will be relying more and more on overhead systems, but also we're going to have to also rely on unmanned systems, whether they're air, surface, or on the water, or even subsurface, to take these observations and measurements and to contribute to the overall intelligence in a given strategic or tactical situation.
I just have one more question too. When you were talking about the military bases, how is the military responding to actually building those structures to be able to sustain with these climate changes?
They are building them better, but not as good as they need to in the face of what we are predicting in terms of what Mother Nature has in store for us. In particular, I think that Army Corps of Engineers, the Navy Facility Engineers, the CBs, are in their design build plans are, for example, at Camp Lejeune in North Carolina, as we rebuild in the wake of Florence last year, where you place buildings, how you control flooding, whether it's with barriers or with better pumps, better backup electrical systems, that is getting better and better. Just that we've got a long way to go.
I'd say, each of the services has their plan to build the base of the future and to really reconfigure both the infrastructure to withstand greater extreme weather events, greater cyber threats, more likely loss of energy disruption. And so there are multiple different components to it. The challenge is putting all those pieces together and then actually doing it and getting it funded across the vast array of military bases. And also being able to think smart about where do we base our force of the future in the climate era. Those decisions are constrained not only by the changing climate, but by politics.
So, in closing, let me just remark that today we've heard from our panel of experts that our national security is facing significant threats from damaging weather and climate change. And it is imperative as a nation to improve our understanding of the Earth system in order for our military leaders to have the best possible intelligence when it comes to accurate and timely forecasts of major storms and detailed predictions of climate change. So I thank all of you for coming today, and please join me in thanking Admiral Ginn, Sherry Goodman, and David Easterling.